Hello guys, welcome to my channel, and today we are going to discuss about the differentiation method. Differentiation topic. So this is under application of differentiation lah. Okay, so we are given the function as fx equals to 2 minus x times x minus 5 square. We need to find the x and y intercept. Okay, so this is quite trivial. So for the first question, so we know that x-intercept, so I shorten it, become x-int. So it occurs when y equals to 0 or fx equals to 0. Okay, so fx or y is the same thing lah. Okay, so we just because we are given fx is 2 minus x times x minus 5 square, so we just let it to be 0, the fx. Okay, so when you have this condition, so you will require to have x minus 2 minus x is 0, or x minus 5 is 0 square is 0. So it's like the fundamental of algebra. When you have a times b is 0, then a equals to 0 or b equals to 0, like that. So we solve this. 2 minus x 0, then you have x equals to 2 or x equals to 5, right? Because when you subs in the 5, you will get 0, and this is subs in 2, you will get 0. Same thing lah. Okay, so this is your x-intercept. Okay, and y-intercept when x equals to 0. So just subs in f0, because x is 0, right? We let x to be 0. You will have 2 minus 0 times 0 minus 5 square. So this is, press your calculator, you will get 50, right? So this is your y-intercept, y-intercept. Okay, so we done this. Okay, so question 2, find the interval where fx increasing or decreasing, like that. So for this case, we need to find the first derivative. So first derivative is like this lah. So first derivative is, you need to use u like this. So you need to use this product rule. So you are given fx is 2 minus x minus 5 square. So you need to know that this is actually your u, this is your v. Okay, so u is 3 minus x, v is x minus 5. So u prime, so you just differentiate this, you'll get minus 1. Okay, because you just differentiate the term with x, okay, with x variable. V prime, sorry, you need to take the whole thing, which is x minus 5 square. So you use product rule, so this bring in front to x minus 5, 2 minus 1, which is 1. Okay, so you don't have to write it, and you times with the differentiation of the inside, which is 1. So you have 2x minus 10 lah when you expand this. Hence you have f prime of x, so you just insert into here. Okay, insert into there. So u is 3 minus x, v prime is 2x minus 10, like that. Okay, plus v. Our v is x minus 5 square. U prime is minus 1. Okay, then we just expand this guy. So this times this is 6x, this times that is minus 30. Is it 30? This times this is minus 4x. Minus 4x, minus 2x square. This times that is minus plus 10x. Okay, then you expand these two, so you have plus x square minus 5 times 2 times x, which is 10x plus 5 square is 25, but you need to times with minus 1, so the sign changes lah. So this is becomes minus, plus, this is minus, like that. Okay, so you need to simplify this guy. So we have minus the 3x square, okay, this and that, all right, and this and this, okay. 26, right? Okay, so it's 10 10 6 is plus 26, is it? It's plus 26. Wait, 2x minus 10, yep. 2x 3 minus, oh, okay, my mistake. So this is supposed not to be 3, so it should be 2, okay, because this is our u, 2 minus x, right? So this is 2, so it's supposed to be okay, so that's a mistake. So 2 times 2 is 4x minus, so 2 times negative 10 is 20, then negative x times 2x is negative 4x, sorry, 2x square, then negative x times negative 10 is positive 10x, okay, don't forget the x. So we reach the same thing except the x term, right? So this 10x plus 10x is 20 times, plus 4x is 24x lah. Okay, this minus 20 and minus 25 is minus 45. Okay, so this is our first derivative lah. Then we need to find the extreme. Extreme occurs at f prime x to be 0, which means that the whole guy here is 0 lah. Minus 3x squared plus 24x minus 45 is 0. So you use your calculator, you will get x minus 3, is it? X minus 5 is to 0. Okay, so this is f prime of 0 lah. So we will end up with x equals to 3 or 5. Okay, like that. So we need to make a table. Okay. So first is so if you see the number line, so x3 x5 is here, so we need to consider all region. Maksudnya kita kena ambil yang kecil dari 3, yang dekat kiri ni, okay, yang dekat kanan, and then yang dekat tengah. Okay, so yang dekat kiri adalah yang x tu kecil dari 3. Okay, x is less than 3, and then the middle one is when x is between 3 and 5, and then lastly is when x is greater than 5, dekat the right side. Okay, like that. So this is our 3 regions. Then we need to check one by one the term. Okay, where is the term? So this is the term we need to check. First one is x minus 3 and then x minus 5. So this is the second term that we need to check. And then lastly, the fx is f prime of x is x minus 3, x minus 5. So where is this taken? So it's from the first derivative lah, from here. Okay, from there. Okay, so it's taken from this lah. Okay. So imagine when x is less than 3. So for example, we take 2. When we subs in 2 here, x is 2. So we'll get 2 minus 3 is negative sign. Okay, negative 1 lah, which is negative sign. Okay, and this is also negative. Okay, because 2 minus 5 is negative lah. And then what if x between 3 and 4? For example, I take 4 between 3 and 5. So I take x is 4 lah. So let's take x is 4, x is 2, x is 6. So subs in the value, x is 4 is 4 minus 1 is positive. Okay, 4 minus 5 is negative. Okay, so we just take the sign, don't have to take the number lah or the value. Okay, what about when x is 6? So when x is 6, both is positive. Okay, like that. And then we need to consider the sign for the f prime of x. So which means that this sign, okay, times with this, because the function is like this, f minus 3 times with the x minus 5. Okay, so when we times the sign, means that negative times negative is positive lah. Positive times negative is negative. Positive times positive is positive. Okay, so we know that the function f increasing. Okay, so positive means the curve is increasing, and then negative means decreasing, positive means increasing, like that. So we know that f increasing at interval minus infinity. So this is from minus infinity to 3. Okay, increasing at, so it is increasing at this lah, two interval. Okay, 5 minus infinity, like that. Then n increasing and decreasing decreasing at interval t3, 5. So the middle one is decreasing. Okay, this one. Okay, or you can say that at x is less than 3 and x is less than 5 lah. Okay, so this is the alternative. So you can write this in inequalities form lah. So this is inequalities form, and the top one, so this one is basically the interval. We said that interval form, like that. Okay, but you can write it in the inequality form also lah, inequality term. Okay, and the question wants to find the extreme point. Okay, so extreme point, because we know that the extreme occurs at x equals to 3 or 5. Okay, where this value is obtained is from here. Okay, we have solved the f0. Okay, sorry, this is fx, right? Not f0. Okay, f prime 0, f prime x, sorry. So we got the extreme from here, f prime x is 0, so we get this value. Okay, x equals to 3 and x equals to 5. Then we just subs in lah. f3 is what? 2 minus 3, okay, times with x is 3, right? So we just subs, or we just gantikan the x value. So this we will get what? I guess, so it's minus 1 times with the, so it's minus 4 lah. Okay, and we just ganti f equals to 5 as x equals to 5. So 2 minus 5, oops, times with 5 minus 5 square. So this is 0. Okay, so our fx function is, you need to remember lah, 2 minus x, 5, x minus 5, x minus 5 square. Okay, so our extreme point, so this is point, occurs at x equals to what? 3, and y is minus 4. So this is the y value. And at x equals to 5 and at 0. Okay, so this is the y value, like that. Okay, so we get our extreme point and also the interval of increasing and decreasing of the graph, right? So the third question is to find the interval concave up or down. Okay, we need to find the inflection point. Okay, so first you can try to find the inflection point first. So inflection point, so it occurs at f double prime x is 0. So because we know that our f prime x is what? X minus 3, x minus 5 kan. So we just expand this guy, x square minus 5x minus 3x is 8x plus 15. Then we need to differentiate this 1 times again. So we get 2x minus 8 lah. Then we just let this to be 0. So we'll have 2x is 8, then x is 4, like that. Then we need to do the table again. Okay. So just consider at 2 value lah, 2 region. At x less than 4 or x greater than 4, like that. So only 2 region. Okay. Okay. And then we need to include our f double prime x. So f double prime x berapa? How much? Is 2x minus 8, like that. Okay. So let's take some value. X equals to, for example, 2. Okay, because 2 is less than 4 lah. And for this second region x, let's take x equals to 5. So when you sub 2 here, 2 times 2 is 4 minus 8, so it's negative. So if negative, which means it is concave down, like this. Okay. Right. 1, 2, 3, 4. Okay, like that. And sorry, 2 times 2 is 4, right? 4 minus x is less than 4, which is yeah, I think that's correct. So when we take x is greater than 5, greater than 4, we take x equals to 5. So 5 times 2 is 10. 10 minus 8 is positive, like this. Okay, so it's supposed to be concave up lah. Okay. So it's concave up. This is concave down. Okay. Alright, so let me check my answer first to ensure that everything is correct. Alright, so yes, yeah, so concave up and concave down. Okay, so concave up is when occurs when x is, or in interval form is minus infinity to 4. Okay, and this is 4 until positive infinity lah, like that. Right. Okay, 2x is 5 -8. Okay, so this is our conclusion, and we need to find the inflection point. So we just subs in lah, f4. So f4 is 4 minus 3 times with the, so we need to insert into the initial function. So our initial function is 2 minus x times with the x minus 5 square. So we just insert 4, 2 minus 4 times 4 minus 5 square. So this is minus 2 minus 1 square, which is minus 2 lah. So inflection point is at minus a 4 minus 2, 4 minus 2. Okay, so this is our last question, is question 4. It is to graph, is very easy because we know that the intercept occurs at the intercept is at 2 and 5, right? So it's 2 here, so at here 2, 5, and we have 3, 4. So the intercept occurs at there, 2 and 5, and our y-intercept, y-intercept dekat sini 50. Over here, x-intercept here, and the extreme is dekat 3, -4. Okay, so it's at 3, -4. So let me take -4 to be here. So -4 to be there, then 3, -4 is here lah. So we already see that this is our point, minimum point. Okay, and then our second maximum point is dekat sini lah, our second max or extreme. Okay, so inflection point sebab because less than 4 is concave up lah. Okay, concave, it's supposed to be concave down, is it? So this is concave down. Wait. X less than 4, x less than 4, concave down lah, concave up, up, down, and up, like that. Okay, so we just connect our point lah. Okay, like that. Okay, so Hmm. Hope I divide by 2. Okay, so this is our graph lah. So you don't forget to plot the y equals to fx axis, and this is x. Okay, so this is our minimum point, or this is maximum point lah. Okay, so our inflection point occurs dekat, so -2 here. So inflection point is dekat sini lah. This is our inflection point. Okay, so inflection point occurs there. Alright, so I think that's all from this question. So I hope you understand this short explanation. Alright, so thank you for watching, and see you again.